Hey guys, so this video is going to be on complex probability. Just as a reminder, the probability of an event is equal to the number of favorable outcomes divided by the number of possible outcomes. So we're going to be using this as we go through. So we're going to be also using a lot of the combination stuff that we learned previously, mainly combinations. I don't know if there's anything with permutations. I can't quite remember, but we'll go through here and see. There we go. A fair coin is flipped 12 times. What is the probability of the coin landing tails up exactly 4 times? All right, so this question looks similar to some of the stuff that we did when we were working with multiplication rule. The difference here is that we don't know what order anything's going to happen in. So we just know out of the 12, we're going to have 4 that land as tails. So we have to deal with this one a little bit differently. So let's start by remembering that a probability has the total number of possible outcomes on the bottom. And I don't think I got my pen there. I thought I did, but okay. So if I flip a coin 12 times, and I know there's a 50-50 chance or a 1 in 2 chance each time I flip it, that means there's 2 options for every flip. And if I flip it 12 times, that's like multiplying 2 times 2 times 2 because I have 2 options every time. So I would multiply 2 together 12 times. So that's the same as 2 to the 12th power. So that would be the total possible outcome would be 2 to the 12th. Those are all the different options if we were to line up 12 coins and see how they landed each time. If we want exactly 4 of them to be tails, then we know that we're flipping 12, and out of those 12 we want to choose 4 as being tails. So 12 choose 4 over 2 to the 12th power. Now in this video I'm not actually going to evaluate these, but you could grab your calculator and do that. So 12 choose 4 over 2 to the 12th would give us the probability that exactly 4 of our coins landed tails. Okay, let's go ahead and take a look at the next one. So a test consists of 12 true-false questions. Again, because it's true-false, that's a 50-50 chance each time, right? There are 12 questions. A student who forgot to study guesses randomly on every question. What is the probability the student answers exactly 2 questions correctly? So again, because there's a 1 in 2 chance for each one, it's 50-50. There are 2 possible outcomes for every test question. So 2 to the 12th is going to be the total possible outcomes of all of those test questions if I'm guessing true or false. Now, what is the probability the student answers exactly 10 questions correctly? So if we were to line up the trues and falses and which ones are correct and which ones are incorrect, we need to take our 12 total questions and we would need to choose 10 of them to be correct. So our probability would be a combination of 12 choose 10 over 2 to the 12th power. Okay, and again, I'm not going to evaluate it, but I would want you to do that on your homework. Okay, a jar contains 4 black buttons and 6 brown buttons. If 5 buttons are picked at random, what's the probability that exactly 2 of them are black? So we have a lot of numbers in here. We got to kind of break this down. So if there are 4 black and 6 brown, and that's all that's in there, we have altogether we have 10 buttons. So that's our total number of buttons. If 5 buttons are picked at random, so we're going to pick 5 or choose 5. So in our combinations, our 10 would be our total, and we're choosing 5 of them. So this is going to be all of the total options. Okay, that would be our total number of possibilities because I have 10 buttons and I'm choosing 5 of them. Now, we want to know what the probability is that of those 5 that we choose, exactly 2 of those are black. So we have to think about if 2 of these are black, so if I choose 5, there's 5 altogether, now I have a different combination here. So my number of possibilities for choosing 2 black out of 4 would be 4 choose 2. And then I still need to think about, because this is only accounting for 2 of those buttons, I have to account for the other 3 that makes up the total of 5. And so I know that of the other buttons that are there are 6 brown ones. And I also know that if I choose exactly 2 black ones, and I'm choosing 5 altogether, that 3 of them must be brown. So I'm going to multiply the number of possibilities for getting 2 black buttons times the probability of getting 3 brown buttons out of the total number of buttons. So a couple of things to notice here, and this I kind of hesitate to say because it's not necessarily true every time, but anytime you have this type of problem, notice that these 2 numbers here, the numbers that are talking about our colors of buttons, those add up to the total number of buttons. And then the number I'm choosing of each one of those is going to add up to the total number I chose overall. So again, you would go ahead and you would put this in your calculator and actually calculate this, but I'm going to skip that part for the video. A technician is launching fireworks near the end of a show. Of the remaining 15 fireworks, so we know there's 15 total left, 7 are blue, so we've got 7 blue, and we have 8 that are red. Okay, so we have 7 blue and 8 are red. If she launches 6 of them in random order, so 6 get launched out of the 15, what is the probability exactly 2 of them are blue? So probability 2 are blue, and this is exactly again. So we just need to think about if 2 are blue. So our total number of possibilities would be we'd have our total number of fireworks, and we are launching 6 of them. So our N would be 15 and our R would be 6. And that's for the total, or like the entire thing. We have 15 fireworks all together. We're going to shoot off 6 of them. So how many ways are there to arrange these 6 fireworks out of the 15? It's kind of like the chairs, right? If I had 15 students and 6 chairs, it's the same thing. So now I need to think about what's the probability then of getting exactly 2 blue ones. There are 7 blue ones altogether, so I would just do, of the 7 available blue ones, I'm going to choose 2 of them. But if I do choose 2 red, and I'm choosing 6 altogether, that means that of the, 2 blue ones, if I'm choosing 2 blue ones, and I'm choosing 6 altogether, that means 4 of them are going to have to be red. And there are 8 choices for red. So I would have to multiply the probability of 2 blue times the probability of 4 red over choosing the 6 out of the 15. So this would be the formula that I would want to use to calculate the probability. Okay. All right, this one looks very similar, so let's take a look at it. It says, a technician is launching fireworks near the end of a fireworks show. Of the remaining 11 fireworks, okay, so that's the total number right there, 5 are blue and 6 are red. If she launches 6 of them in random order, so that's how many she's going to launch, so I'm going to call that R, this is going to be N for the overall problem. In a random order, what's the probability at least 4 of them are blue ones? Now look here how it says at least 4. So this is a little bit different. Before it said exactly 4, so we only had to think about when we had 4 blue ones. This time we have to think about when we have at least 4 blue ones. Okay, so let's go ahead and start with the bottom of our probability first. What are the total number of options here? So if we have 11 total fireworks and we are choosing out 6 of them, our total number of possibility is going to be 11 choose 6. Now if we want, let's first look at what happens if it's exactly 4 blue ones. So if it's exactly 4 blue ones, then I would just take the number of blue, so I have 5 blue, and I would choose 4 of them. Now if I choose 4 blue and there's 6 I'm choosing all together, that means there's 2 I have to choose from the other colors, so that would be, there are 6 red, so that would be 6 choose 2. So this is just the probability for when there is exactly 4, but we need to look at the probability for when there are at least 4 blue ones. Okay, so if there are at least 4 blue ones, we know that there are 4 blue, or 5 blue, or all 6 of them are blue. So it takes into account all 3 of these cases. So we just wrote down what happens if there's 4 blue, but if we have an or in here, we're going to actually end up adding on to this, and we're going to have to look at the probability when there are 5 blue and when there are 6 blue, because all of these will count as our probability for at least 4 of them being blue. So if there are 5 blue, this would change just a little bit. It would be 5 choose 5 times. Now, if I choose 5 of them that are blue, then that means there's just 1 left over to be red. So it would be 6 choose 1, and then over our total number. So I would have to add these together. Now I'd also need to look what happened if there were 6 blue, but notice here that there are not 6 blue available. The most we can have is 5. So we would, at least having 4 blue would be meaning that we have 4 or 5. So these are the only 2 cases in this one that we would need to look at. So I would need to go ahead and evaluate this and evaluate this and then add them together to get the total probability, okay? That's because we had different options. We have these ors in here. So that if you ever have those different options, if it ever says at least or at most, you're going to have more than one you're going to need to add up. So each one looks the same as what we were doing on the previous slides, but if there are more than one option, we need to add them together, okay? A gardener has 13 identical looking bulbs. So this is the total amount, right? So we can call it N if we want to, of which, let's just write total here. So a gardener has 13 identical looking tulip bulbs, of which 7 will produce yellow tulips. So we've got 7 yellow, and 6 will become pink. He randomly selects and plants 8 of them and gives the rest away. So he is choosing 8 out of 13. So that's going to be our total number of possibilities. He has 13, he's choosing 8. When the flowers start to bloom, what is the probability that at most 5 of them are yellow? Okay, so now we got to think about that. So at most 5 are yellow. So if we could first think about 5 are yellow, we have 5 yellow. At most means we don't want more than that, right? So we could have 5 yellow, we could have 4 yellow, we could have 3 yellow, 2 yellow, 1 yellow, or we could have 0 yellow. So these are all the options that we're going to have to add up. There's 1, 2, 3, 4, 5, 6 of them that we would have to add up. Now, because there's so many of them, what we could do instead is we could use the fact that the probability of a complement is 1 minus the probability. So remember what a complement is. So as a side example over here, let's say I'm rolling a 6-sided dice. If I do that, wow. If I roll a 6-sided die, what's the probability of getting a 1? Okay, so the probability of getting a 1 would be 1 out of 6, right? So that's the probability. Now, something that we could look at instead is what's the probability of the complement of 1? So 1 complement. So if I have 1 complement, that means all of the things in the sample space, and the sample space would be 1 through 6 for a 6-sided die, right? So what's the probability that I get, basically this is saying anything but 1, right? Anything that's not 1 in the sample space. So 2, 3, 4, 5, and 6. So the probability of that would be 5 out of 6, right? So notice here that the probability of 1 and the probability of its complement are going to be, if I add them together, I'm going to get 1. Because 1 6 times 5, not times, plus 5 6 is equal to 6 6, which would be 1. So because that's true and it's always true, I can always find a probability by looking at the complement and then subtracting it from 1. So 1 minus 5 6, which is the same as 6 over 6 minus 5 over 6, is equal to 1 over 6. So that is the same as the probability of the event happening. So another way to say that is the probability of an event happening is equal to 1 minus the probability that it did not happen. Okay, so I think that's going to be easier for us here, because we could write down each of these probabilities. What's the probability I get 5 yellow or 4 yellow or 3 yellow or 2 yellow? But that's going to take quite a while, and I'm going to have to add up a lot of stuff. So instead, let's look at the complement of this. So if I have the probability that at most 5 of them are yellow, and this is what that means, like there's not 6 yellow and there's not 7 yellow, I am going to actually look at the complement. So the complement would be that there are 7 yellow. So let's write complement right here. Or 6 yellow. We can't have 8 yellow, all 8 of them yellow, because there's only 7 yellow available. So in this case, I would only have to add up these two cases, because this is the complement, 7 yellow and 6 yellow. I could add those together and then just subtract the probability from 1, and it would give me the same probability as adding all of these up. So it's going to be a lot less work. So let's go ahead and do that. So I'm going to go ahead and put a plus right here. We're just going to do 1 on this side and 1 on this side. So the probability that I get 7 yellow, if I'm choosing 8 fireworks, oh no, wait. So if I have 7 yellow available and I choose all 7 of them to be yellow, that means I have just 1 left over in the 8 that I'm choosing to be pink. So I would have to times this by 6, choose 1. If I have 6 yellow, then of the 7 yellow available, I would be choosing 6, and then I would be multiplying that. That means that of the 8 that I chose, 2 would have to be pink. So this would be 6, choose 2. And then I could go ahead and I could put this in my calculator, get this calculated, and I could find that probability. But I need to remember that this is the probability of the complement. So this is the event, this is the probability the event did not happen. So I would have to do 1 minus that in order to get the probability, okay? Notice here, this time I put these on top of the same denominator, but if I were to put them both over the denominator separately, that's the same fraction, okay? So you could do it this way, and that's fine. Just add all 6 of these up, but this is just a lot shorter and a lot less work to take the probability of the complement and then subtract it from 1, but either one will work, okay? All right, so last example, if you're drawing a 5-card hand from a standard deck of cards, calculate the probability of getting the following hands. So of the 5 cards, I get 3 kings, 1 ace, and 1 10. So we've looked at, again, probabilities that were similar to this when we did multiplication rule, but this one is not specifying an order. So when we did multiplication rule, it told us I got a king, a king, a king, then an ace, and then a 10. This one's just saying, if I choose 5 in any order, what's the probability that this is the hand I end up with? So we can't just use the multiplication rule here straight up, but we can think about how many ways there are to choose 3 kings, how many ways there are to choose 1 ace, and how many ways there are to choose 1 10. And then we can put that over the total possibilities, number of possibilities for choosing 5 cards out of 52, right? There's 52 cards in the deck, and we're choosing 5 of them. So this is going to give me the total number of possibilities of hands I could get out of a 52 card deck. Now, kings, I know that in the deck there are only 4 kings. So of the 4 that we have, that we're going to be choosing 3 of them. So what's the probability of choosing 3 out of the 4 kings would be my first thing here. And now I'm multiplying here because this is all one hand, right? 1 ace, there's 4 aces. So again, if I'm just choosing 1 of them, this would be 4, choose 1. And 1 10, again, there's 4 10s. So this would just be times 4, choose 1, okay? So 4, choose 3, 4, choose 1 times 4, choose 1. I would, again, put this in, actually calculate it. I'm just not doing it here for the video's sake because you would just be waiting for me to use the calculator. Okay, so number 2, what is the probability of getting 3 face cards and 2 aces? So again, we have a 52 card deck and we are choosing 5 of them. So this is all the ways to do that. There are 12 face cards, 4 from each suit. So we are going to take our 12 face cards and choose 3 of them. And of the aces, there are 4 aces. So we would take 4, choose 2. And that would give me the probability of getting that hand, okay? I know these can be challenging, but the more you practice it and the more examples you try, the easier it will get. If you have any questions, please don't hesitate to reach out, and I hope you have a great day.